The Bronsted-Lowry theory gives a more general definition of acids and bases. It defines acids and bases in terms of their ability to transfer protons. Click the Start button to view what happens when hydrogen chloride is dissolved in water. According to the Bronsted-Lowry theory, hydrogen chloride is an acid as it donates a proton, H+ ion, to water. The Bronsted-Lowry theory defines a base as a substance that can accept a proton. Which substance acts as a Bronsted-Lowry base here? Answer: water. Click the Start button to view what happens when gaseous ammonia and gaseous hydrogen chloride is released from their aqueous solutions. Click the Molecular View button. Is hydrogen chloride an Arrhenius or a Bronsted-Lowry acid in this reaction? Discuss and click Next. Answer: hydrogen chloride is a Bronsted-Lowry acid as it donates a proton to ammonia. Thus, unlike the Arrhenius theory, the Bronsted-Lowry theory can be applied to reactions that do not occur in aqueous solutions. According to the Bronsted-Lowry theory, a conjugate base is obtained when an acid loses a proton. Identify the acid in the reaction above and click on its formula. CH3COO- is the species left after ethanoic acid CH3COOH has lost a proton. It is therefore the conjugate base of ethanoic acid. Now, click on the H2O. H3O+ is the species obtained when a proton is added to the base H2O. H3O+ is called the conjugate acid of H2O. The above reaction is a reversible reaction. Identify the acid conjugate base pairs for the reverse reaction. Drag and drop the correct formulae into the appropriate boxes below. Click the Conjugate Base button. Identify the conjugate base of each of the species shown. Drag and drop the correct formula into the appropriate boxes. Click the Conjugate Acid button. Identify the conjugate acid of each of the species shown. Drag and drop the correct formula into the appropriate boxes. Summary: the Bronsted-Lowry theory gives a more general definition of acids and bases. It defines acids and bases in terms of their ability to transfer and accept protons respectively. According to this theory, an acid is a substance that can donate a proton to another substance. A base is a substance that can accept a proton. The conjugate base is the species that is obtained when one proton has been removed from a Bronsted-Lowry acid. The conjugate acid is the species that is obtained when a proton is added to a Bronsted-Lowry base. The Lewis theory of acid-base reactions defines a base as an electron pair donor and an acid as an electron pair acceptor. Click on NH3 and BF3 to view their structure. Which substance can act as a Lewis acid? Discuss and click Next. Answer: the boron atom in BF3 has only 6 valence electrons. It can accept a pair of electrons from the NH3 molecule to achieve an octet of electrons. Click the Start button to view the acid-base reaction. One advantage of the Lewis theory is that it includes oxidation-reduction reactions as well. It provides a much broader definition of acids and bases. Summary: a Lewis acid is a substance that can accept a pair of electrons. It is an electron pair acceptor. A Lewis base is a substance that can donate a pair of electrons. It is an electron pair donor. The Lewis theory provides a broader definition of acids and bases than the Arrhenius theory and the Bronsted-Lowry theory.